All right, more examples of things you can do with limits already and things that you have to keep straight, right? Here's limit as x approaches a finite number of a rational expression. Here's the limit of a rational function at plus or minus infinity. So you have to keep straight the difference. If I'm doing limit as x approaches negative infinity, x approaches positive infinity, all right? So the key thing to think of is if you see infinity down here, do not factor. You will not factor this. Instead, you're going to look at the degree rules, right? If I have a real number, I'm going to factor, simplify, and substitute. If I have infinity or negative infinity, I am not going to factor. I'm just going to look at the leading coefficient, right? And if the large degree in the denominator limits 0, large degree in the numerator, it's plus or minus infinity. Look at the signs. And if the numerator and denominator have equal degrees, it's the ratio of leading coefficients, just like you learned about horizontal asymptotes in your pre-calculus in Algebra 2. All right, so here's some examples. Limit as x approaches negative infinity. If the exponents match, it doesn't matter if we're approaching positive or negative infinity, just go with ratio of coefficients. The ratio of coefficients is 3/7, so it's 3/7. So remember, you're only looking at the leading terms, which means the terms with the highest exponent, regardless of what order it's written. Okay, oh, I see highest exponent in the numerator. All right, highest exponent in the numerator. So if I have leading a larger degree in the numerator, I'm going to have plus or minus infinity. Analyze the signs. So if I had like negative a million here, all right, I would have a negative on the top and a positive on the bottom. So that's how I know it's negative, all right? I know it's infinity either way. But just looking at what would happen if I put a large negative number in here, because it's negative infinity, what would happen if I put in a large negative number? That tells me whether it's positive or negative infinity. Okay, limit as x approaches negative infinity. Oh, okay, so again, x is approaching negative infinity, and the degree of the numerator is higher. Okay, but this time, if I put in a negative number, top and bottom, I'm going to get positive either way because I have even exponents on the top and bottom. So the leading terms are going to be both positive. That means I'm going to positive infinity. Infinity because leading highest exponent was in the numerator. Positive because when I plug in a negative number to the leading terms, I get positives. All right, and then this one. So watch out for things being written in different orders. So I'm not going to look at the 28. I'm looking at the squareds. Right, so I have matching degrees top and bottom, so I'm going to use 3/7. So this is once again 3/7. Oh, but that's tricky, isn't it? I'm glad I had to think about that. So because this coefficient is 3, but this coefficient is actually -7. The coefficient is -7. So if I think about a large positive number in here, x squared, positive, negative, it's going to be -3/7. So just, think about the signs of your limit. The limit as x approaches negative infinity would also be -3/7. Okay, more limits. So then the other thing is you need to know some graphs. So there are known graphs. There are graphs that you just know. These are some examples of them. You know the graph of tangent x has vertical asymptotes at all the pi/2's. So here's pi/2, here's -pi/2, here's 3pi/2. This is a graph you're just supposed to know. All right, this graph goes like this. That's how it goes. I'm interested in pi/2. I'm approaching pi/2 from the left. So as I approach pi/2 from the left, my y values are going up to infinity. This is a one-sided limit, so it equals infinity. Because the graph equals y equals tangent x has an odd vertical asymptote. All right, ln of x, you need to know what that graph looks like. All right, that graph looks like that. You need to know that. You will be expected to know that. The limit as x approaches 0 from the right. As we approach 0 from the right, the y values are going down to negative infinity, so that limit is negative infinity. Limit as x approaches negative infinity of e to the x. We all know what e to the x looks like. And this is what it's about. It's about, do you know what all these graphs look like? All right, so here's the graph of e to the x. It goes up like that. It's exponential, right? But I'm going to negative infinity. So as the x's go out here to negative infinity, the y's are going to approach 0. All right, but as the limit as x approaches positive infinity of e to the x, here's e to the x. We're going to positive infinity. As the x's go to positive infinity, the y's also go to positive infinity. Therefore, that limit is infinity, okay? So study those. Think about those graphs. Know those graphs. And those are things that you need to be able to do. Find all these different kind of limits. And yeah, that's pretty much covers it for Chapter 2, also known as Unit 1. Your homework is correctly stated here and on Google Classroom. And then I think Monday we'll do just sort of some, I'll post some things that are just sort of review. I think we're going to do an AP Classroom thing. And then, yeah, I think Wednesday or Thursday I'll assign that assessment and give you over the weekend to do it. All right. Also, by the way, homework is now due Monday. I realized that I'm assigning a lot of work on Thursday, and then making it due Friday means you've only got 24 hours to do it. And I would rather you have time to deliberate and do it correctly. So homework from now on for the rest of the year is going to be due on Mondays by 11:59 p.m. That's to give you the weekend to do it. All right. Everybody have a good day.